Boom. Hi. Chapter 7. Basic integration. Why, you restart? Hello and welcome back to Calculus 2. There you go. Chapter 7's first section is on basic integration. So we are reviewing the basic ideas from basic integrals and the use substitution, which is what you will be using for every single problem in Chapter 6 exam. So you know the list of basic integrals, right? You know that the integral of a constant dx, well, constant k, is kx plus c. You know that the integral of 0 dx is just 0 plus c, obviously. Then you know that the integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. Integral of e to the x dx is? Perfect. And then if this e to the x has a in front,
it's going to be a ln.
Or
it's going to be e. You forgot the a.
A is in the denominator.
Not on top.
On top is for derivative. Oh, yeah, you're right. Sorry. Yep. There's ax over here. You're right. What's the integral of 1 over x dx? The absolute value. Have to have the absolute value there. And then integral of, let's go to trigs. Sine x dx is?
Cosine.
Negative cosine. Plus c, yes. Integral of cosine x dx. Integral of tangent x dx. Nope, it's ln. It's not basic, right?
1 over ln,
Yeah, 1 over secant squared plus tangent. Yeah, so it's not a basic. How about the secant squared? How about cosecant? How about secant x tangent x? Cosecant x cotangent x? Negative cosecant. Plus c. What I gave you here is the list of basic integrals that you memorized. If you don't like any of these, be my guest and use Riemann sums instead. You have to understand, guys, these are the shortcuts. This is what makes it easier, right? Like multiplication table makes repeated addition easier. These are your shortcuts, so you don't have to do the limit definition from the Riemann sum. That's the bottom line. Now that you know these, we go and we just review a few of those U sub questions. So say you have integral of x over 3 times e to the 2x squared dx. It's just a problem that looks annoying. You immediately ask yourself, is this a basic integral? The basic integral. No. So it is exactly. If it's not left, it's right, right? So do the U sub. Go.
multiplication.
Okay.
That's why I said I got like my happy that they eat X square. It's a little closer to X square with a D dx on the X is just one times 1/3 is 1/12. Yeah, it's got these D. There's no plus. Oh yeah, there's good.
It is a plus C. It's a plus C minus 1.
Yeah, that's why I say out loud is what it is.
1 over 12. 1 over 12 e to the 2x squared plus 6. Yeah.
Like the formula that you have to get, I don't think it's wrong.
That's what we did at the lab.
Yeah.
We're all like, you got 8. Right. Now what? We did the easy part. Move the shoulders so far.
But I think it's maybe a first one the other kid got it. I got like 5 pi. I got like
Knock on wood or something right now.
15, like, put down a 5 back. I wish I had to be a Y. They could have, I don't think they're totally right about that. It's totally weird. The battery, you put in a entire thing and you PM. I didn't think it's
Oh, the first one is, alright, so we got integration by parts, and then the trig integrals. Trig's partial fraction decom, other integration strategies, numerical integration, and yeah.
All right, guys. First order of business is to kick 1/3 in front of the integral, so this looks a little bit easier. We see that we have a function derivative pair, so u equals 2x squared du equals 4x dx. That's 1/3 integral of e to the u du. Or no, I lied. I need a 4 and a quarter in front. You gotta stop me when I start doing these things. So that's a 12. There we go, much better. And we have 1 over 12. E to the u is e to the u, so e to the 2x squared plus c. Or it's a -1 on the roster in that case.
Alright, we're at that point. We're gonna have to calculate it.
Oh.
Everyone can hang now.
All right, so let's take a look at another one, the integral of ln 2x over x dx.
Is it like 1 or 2x over x?
It's 1, yeah, you can rewrite it as 1 over x times ln, yeah.
1 over x, like ln 2.
Yeah, ln 2x dx. Any ideas? U equals ln 2x. Yep. So u equal ln 2x. du is equal to, we put 2x and then derivative of this is 2 and they cancel, so it's just 1 over x dx. Great. So the integral is just u, du. Yeah. And then it's u squared over 2 plus c. And then we have 1/2 ln squared 2x plus c. So
may I ask you, is it possible, like, I get 1 over x and separate out the ln of 2x, in which I got ln of x, and then you're bring 1 over 2x times.
how do you separate ln 2x?
You got 1 over x times by ln of 2x,
Yes.
in which I put down ln of x times it by 1 by 2, 2 divided by 2x. Like,
Oh, that's for that's your dx. Yeah, that's what I had, but I canceled the 2's. Okay, so yeah, it's 1 over x.
okay, but
The 2's cancel, right?
yeah, 2 cancel, but you forgot you had another x there.
All of this is u, and all of this is du. So it's just u times du.
Right? Well, that's the common answer.
I'm sorry?
That's the common answer, the 1/2 ln 2 squared.
Yes.
That's going to be the common.
That's it. So they have some really tricky integrals that are not, you know, exam worthy, but they pop up here and there. So let's see how this goes. 6 minus x to the 4th over x squared plus 4 dx. Got it? What's the method we have to use? Anyone?
Tangent, inverse.
You can't, because you have the denominator. You can't split it up. It looks like tangent, but it's not. Eventually we'll play the role, but nope. No u sub. No function derivative pair. Long division of polynomials. I know. I know, but that's it. Long division of polynomials. You have to divide x squared plus 4 into the, yeah, so you divide this into that one, you do the division, see what's left over, and then hopefully your tangent pops up. You want that tangent. Oh, that's your house.
Yeah, so it's not gonna bother.
Let's go, long division, guys, while we're still young.
So what did I do here? What did I do? Like that?
So the way we do it is we put those placeholders, right? So we have x squared plus 0x plus 4 divided into negative x4 plus 0x cubed plus 0x squared plus 0x plus 6. I put some placeholders there. So x squared goes into negative x to the 4, negative x squared times, multiply it back, we get negative x to the 4, and then 0x cubed, and then negative 4x squared. And then we subtract, these cancel. When we subtract, we get positive 4x squared plus 0x plus 6. X squared goes into x squared plus 4 times. And then multiply it back, we get 4x squared plus 0x, and then plus 16. And then when we subtract, we get the remainder of negative 10. So this integral is actually negative x squared plus 4 minus 10 over x squared plus 4. Easy, easy inverse tangent, right? I know, it's awesome. So you do the long division, and it turns out to be, from there, easy.
I think you can actually do the tangent inverse. You should do it like you get take my x to the 4 and I can do a tangent like this. Right here.
For this problem?
Yeah. Whatever it is.
Well, that's, we have, we have 6 minus x to the 4.
Yeah.
What we have is,
Or like 4 times. No.
you can't do it that way. This is the only way to do it that way. You put it mathematically, let's see what we're going to have. You have to do long division on this type of problem. You have to make this.
And if this doesn't work, then it's partial fraction decomposition when we learn it later. When you have polynomial divided by polynomial. These things get more interesting. What else is cool? Ooh, this one. How about this one? You remember this problem from somewhere, I see. Or from him? Yeah, I believe this problem pops up on a homework or somewhere.
Yeah, I asked you.
Oh yes, you asked me about this problem. Yes. So this is a little bit different animal than you. Depends on what level you learn Calc 1 U sub. I might have to adjust some grades. We'll see. from Calculus you can't do it now. Let's go check because the one. So what should we do here?
We just so this u equals x plus x minus 1.
Very good. So du is?
Du is equal to dx.
Good. So what I'm going to do with the extra x over here?
If you want to do u plus y 1 equals x.
Nice. X is u plus 1. That's called the back substitution.
I just taught that to somebody at the tutor on Saturday, which is kind of concerning.
What happened?
I taught that to somebody at the tutor center this morning.
This morning.
Yeah, like they had no idea.
In which course was that person?
What do you mean?
Whoever you tutored.
I taught this to a tutor.
Oh, to a tutor. Okay.
That was like,
That's some next level there.
that's what I was thinking. That's what that was.
So at this point you just distribute. Square root of u is 1/2, right? So we get u to the 3/2 plus u to a half du, and we have it. Oops. U to the 5/2 over 5 half on top plus u to 3/2 or 3 plus C. It's 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus C. And crash. Yep, as soon as I want to write plus C. So all I need to do now is to write everything from scratch, and that's it. I think we made it this time. So that was a short review. There are more techniques. You can sometimes chain u subs, multiple u subs within a problem. You can deal with completing the square, another algebraic thing that might pop up. But as you can see, u sub plays the central role, and this particular problem is called back substitution because of this part here. So you are solving your u sub for x, and you're back substituting that here to give you this piece, because you have this as u and you have this as du, but you didn't have this piece until you worked it out. So this trick works sometimes as well. Sometimes it works. So this is called back substitution if you look it up in literature. All right, so that's the little review. Now we're going to take a short break. After this, we'll just work out problems of chapter 6 and preparation for the exam tomorrow. So you can enjoy in peace.